let's quickly see if we are live. I think we are. So yeah, I maybe need to update the stream title. Today we are going to start chapter 8, common collection. So let me do this. And maybe we will try Rustling after. Think we are good. So yeah, basically last stream we finished the chapter 7 where we found out what is modules, create packages, etc. And we found out about its scopes, things like this. And today we will start the chapter 8. I think we will pass through first section 8.1 and then I think I'm going to try Rustling because we pass over a lot of information in this book and I feel like I want to try to practice a bit, because if you're not practicing, I'm not doing the streams every day, so the information start being forgotten. So a bit of practice I think will increase memorizing the things and understanding it better. So I heard a lot about this Rustling before, so maybe it's something good. I haven't tried yet, so we'll try to find out how it's work on the stream. So let's start with the book and the chapter 8, common collection. Rust standard library includes a number of very useful data structures called collections. Most other data types represent one specific value, but collection can contain multiple values. Unlike the built-in array and tuple types, the data these collections point to is stored on the heap, which means the amount of the data does not need to be known at compile time and can grow or shrink as the program runs. Each kind of collections has different capabilities and costs, and choosing an appropriate one for your current situation is a skill you develop over time. In this chapter we'll discuss 3 collections that are used very often in Rust programs. A vector allows you to store a variable number of values next to each other. String is a collection of characters. We've mentioned the string type previously, but in this chapter we'll talk about it in depth. Okay, a hash map allows you to associate a value with a particular key. It's a particular implementation of the more general data structure called map. Okay. To learn about the other kinds of collection provided by standard library, see the documentation. We'll discuss how to create and update vector, string, and hash maps, as well as what makes each special. So yeah, there is documentation to collections, and you see there is a bunch of that. Vec might be a vector. and we will learn about it. Linked list is another collection. The hash map we will learn. Bit-tree map is different one. Set and etc. So this is all in the std collections. So the main thing about it, the array in the Rust is something that have defined length. So at the compile time we knew the size, I guess. That's why I don't know, it could be the but yeah, like you see this sentence, unlike the built-in array and tuples, the data in this collection point to the stored on the heap. So this vector string hash map is something that's stored in heap and we don't know the size. That's why it's worked differently. So section 8.1 is about storing list of values with vectors. So we learn about vectors. Let's jump straight into it. The first collection type we'll look at is vec angle brackets t, also known as vector. Vectors allow you to store more than one value in a single data structure that puts all the values next to each other in memory. Okay, values stored next to each other in memory. Vectors can only store values of the same type. They are useful when you have a list of items, such as the lines of text in the file or the piece of item in shopping cart. So yeah, it's like alternative to array, but we can mutate, like add something to this array, remove items, etc., as I understand so far. The creating a new vector. To create a new empty vector, we call the vec_new function as shown in listing 8.1. So let's create a new project. Maybe cargo new vectors 8. Go to main RC, remove the print, and so let's create a variable vector. Let v will be vec I32 equal new. So cargo build, yeah, it's compiled fine. So note that we added a type annotation here because we aren't insert any value into this vector. Rust doesn't know what kind of elements we intended to store. This is an important point. So yeah, we added this type because the vector is empty and there is no values which Rust can use to identify which type it is. So if we have some predefined values, we maybe can drop this I32, and I think we will find out its user in this section. So vectors are implemented using generics. We'll cover how to use generics with your own type in chapter 10. For now, note that the vector angle brackets t type provides by the standard library can hold any type. When we create a vector to hold a specific type, we can specify the type within angle brackets. Okay, in listing 8.1, we've told Rust that the vector type t in V will hold the elements of the I32 type. So yeah, basically this is, here we can place the type of our elements if it's cannot be determined by default in Rust. We can actually quickly test. If we remove it, we immediately, sorry, it's interesting. Let's do cargo build, and yeah, we see the error. Expect at least one generic argument. So you see here generic argument, missing generic for struct vec. So yeah, let's continue. More often you'll create a vec_t with initial value, and Rust will infer the type of value you want to store. So we rarely need to do this type annotation. Rust conveniently provides the vec exclaim mark. So exclaim mark means it's a macro, which will create a new vector that holds the values you give it. Listing 8.2 creates a new vec I32 that told that values 1, 2, and 3. The integer type is I32 because that's the default integer type, as we discussed in the data type section of chapter 3. Sure, let's try let vec we don't need to do anything here. We can just use vec macro and do it exactly as actually print it. Now let's do cargo run. Yeah, it works. And if we do cargo run, yeah, it showed the empty vector. Okay. So now, since we have the vector, to create a vector and then add elements to it, we can use the push method as shown in listing 8.3. Okay, so this is something, if you, for example, new JavaScript, we have an array, we can push into it. So looks really common. And just push some number. Let's do the 10. And let's push something to vector as well. For example, 20. So let's print after the push. Okay, you see we have some errors. Might be mutable. Yeah, sorry. So cargo run, and you see there is before push and after push. Everything is expected. And there is mat as well to make the vector mutable, of course. As with any variable, if we want to be able to change its value, we need to make it mutable using the mat keyword, as discussed in chapter 3. The number we place inside are all of the type i32, and Rust infer this from the data, so we don't need the vec i32 annotation. Oh, really? Can we do it like this now? And it will work? So Rust can pick up the type not just from initial value, but uh, from value we used later on. Yeah, this is interesting. I don't think I saw something similar in different languages. But yeah, looks really cool. So, reading elements of the vectors. There are two ways to reference a value stored in the vector, via indexer or using the get method. In the following examples, we are annotated the types of the values that are returned from the functions for extra clarity. Okay. So get method. For the extra clarity. So what we have here? We have a vector created. Well, let's actually just copy this snippet. Maybe delete this code, or maybe not delete, but just comment it. And so what is going on here? We have vector i32. Now we can create sort is reference to the sort element. Okay, and we can print it. Then we use get, which will be option of reference i32. Oh, this is finally we see how the option works. This is really interesting. So this is the problem, for example, for me in the TypeScript. If I get value by index in array, it's never really convince you that it might be undefined, so there is no value. In case of Rust, I think the get it's force you, like it's return the option type, And since you can guarantee the index you place here is exist, the option might be or might not have value. And in this case, we use match of the option type. In case some value we print it, in case none, we print there is no third element. So, but what happened here in this case? This is interesting. Let's quickly run first this version. And then let's try to do not have this third element, and it panicked at index autobound. The len is 2, but the index is, but if we do build cargo build, everything is fine. So this is actually not quite safe solution, as I see. Trying to assess the index, but we don't really know if it exists. Usually in the program there could be situation which like don't guarantee if the index exists in the array. And if we use get, we have optional type and we are safe. But if we directly access the index, it's not safe anymore. Okay, let's continue with the book. So note a few details here. We use the index value of 2 to get the third element because vectors are indexed by number starting at 0. Okay. Using reference and the square brackets gives us reference to element at the index value. When we use the get method with the index passed as an argument, we get an option that we can use with match. The reason Rust provides these two ways to reference and an element is so you can choose how the program behaves when you try to use an index value outside the range of existing elements. As an example, let's see what happens when we have a vector of 5 elements and then we try to access an element at index 100 with each technique as shown in listing 8.5, which we already did actually. So when we run this code, the first square brackets method will cause the program to panic because it references a non-existent element. This method is best used when you want your program to crash if there is an attempt to access an element past the end of the vector. Okay, this sounds really exciting. Like when you want your program to crash. Do I want my program to crash? In which universe? I'm not really sure. But yeah, it is what it is. When the get method is passed an index that is outside the vector, it returns none without panicking. You would use this method if accessing an element beyond the range of the vector may happen occasionally under normal circumstances. Your code will then have logic to handle having either some or none, as discussed in chapter 6. For example, the index could be coming from a person entering a number. If they accidentally enter a number that's too large and the program gets a non-value, you could tell the user how many items are in the current vector and give them another chance to enter a valid value. That would be more user-friendly than crashing the program due to a typo. So, yeah. Okay. When the program has a valid reference, the borrow checker enforces the ownership and borrowing rules covered in chapter 4. To ensure this reference and any other references to the contents of the vector remain valid, recall the rule that states you can't have mutable and immutable references in the same scope. That rule applies in listing 8.6, where we hold an immutable reference to the first element in a vector and try to add an element to the end. This program won't work if we also try to refer to the element later in function. So create a vector, have a reference to the first element, then push and print. Let's try it. Let's paste it in the top and cargo run. Immutable borrow occur here. Mutable borrow occur here. So yeah, it will work if we sorry, will not try to print it here. So the borrowing stops. Guess even if we try to print it before we do mutation, I guess it should work. Yeah. Like this is last use of our first, so it's kind of end of life, end of borrowing here. Here we do mutation, so some mutable reference is used or something like this, but yeah. So compiling this code will result the error. The error cannot borrow v as mutable because it is also borrowed as immutable here. So borrowed immutable here, and we cannot borrow it here. Immutable borrow later use here. If it's not used, we are fine. So this code in listing 8.6 might look like should work. Why should a reference to the first element care about changing at the end of the vector? This error is due to the way vectors works. Because the vector put the values next to each other in memory, adding a new element onto the end of the vector might require allocating new memory and copying the old elements to the new space. Yeah, this is actually was a question in my mind. What if the vectors place item next to each other in the heap? What happened in the situation when there is no more space in the place, like, I don't know, draw online. Like we have something like this. It's our vector, and this is the heap, and there is stored some, I don't know, some other string, and they want to push. So what happened, this part is deallocated and it's find free space for and this is our new vector here. Yeah, now it's clear. So if there isn't enough room to pull all the elements next to each other where the vector is currently stored, in that case, the reference to the first element would be pointing to the allocated memory. The borrowing rules prevent program from ending up in that situation. So yeah, basically, if we have reference to this, like first, so after we pushed, this part is deallocated and this will be invalid. That's why the Rust prevents us from such problems. It just not allowed to do this. So you have stopped to using the first. If you want to use it, you can do it later again. So like this, I guess. Cargo run, and you see no potential problem in such case. Note, for more on the implementation details of the vector T type, see the Rustonomicon. What is... So this is docs Rustling and example implementing vector. Oh, it's actually interesting. Maybe we should look into it someday. So it's docs nomicon. What is the Rust nomicon? Warren, this book is incomplete, documenting everything and rewriting outdated parts take a while. See the issue tracker to check what's missing, outdated, and if there are any mistakes or ideas that haven't been reported, feel free to open a new issue here. Yeah, this is, look. Yeah, so this is incomplete and can have some outdated parts, but anyway, what is the Rustonomicon? There's so many different books in this docs Rustlang.org. This is, yeah, quite impressive, I would say. Yeah, a lot of works, a lot of documentation, a lot of effort here. So the dark arts of unsafe Rust. The knowledge is provided as is without warranty of any kind. Okay, this is the Rustonomicon digs into all awful details that you need to understand when writing unsafe Rust programs. Okay. We haven't even written saved one, which I guess is default, but yeah, this is something I guess we should take into account when we want to kind of break some Rust rules about safety, with option the Rust provides us, and we know we need it for some reason. In this case, we need to learn this book, I guess, first. So, should you wish a long and happy career of writing Rust programming, you should turn back now and forget you ever saw this book. It's not necessary. Okay. However, if you intend to write unsafe code or just want to dig into the guts of the language, this book contains a lot of useful information. So, yeah, it might be like if you feel super comfortable with Rust, then and you want to dive even deeper, I guess it's kind of interesting book to read, but definitely not what we need right now. So let's back to our vector section. So iterating over the values in the vector. Oh, iterating, cool. To access each element in a vector in turn, we would iterate through all the elements rather than use indices to access one at a time. Listing 8.7 shows how to use for loop to get immutable reference to each elements in a vector of i32 values and print them. So for in, did we already use for? I think we should. There was about loop and is it control flow? Yeah, there is a loop and there is while and for. Yeah, I feel I almost lost in my memory already, so that's why I'm going to try Rustling after I finish reading this vector section. Would like to do more practice because, like, yeah, I'm not doing this Rust book every day, just streaming like 3-4 times per week, which is not the optimal way of learning it. I guess it will be better to do it much faster, but it is the time I have it, so this is my only option right now. But yeah, let's continue. Iterating over the values in a vector. To access each element in a vector in turn, we would iterate through all of the elements rather than use indices to access one at a time. Listing 8.7 shows how to use a for loop to get immutable reference to each element in a vector of i32 values and print them. And let's go. Comment the code. Yeah, I decided to not do it anything because sometimes, like in previous chapter, I was looking for some code and I think I didn't save it, and it's harder move forward. It's nice to sometimes get back So previous chapter and take a look what you did or even use it, this code. So what we see here, the I in vector reference. So I guess I is reference to I32 and we can print it. Okay. Let's do clear. Then cargo run. So yeah, iterate through the vector 111. Pretty straightforward. Okay. We can also iterate over mutable references to each element in a mutable vector in order to make changes to all the elements. The for loop in listing 88 will add 50 to each element. Let's do it ourselves. So it might be mutable. And I and cannot be applied to the integer, so it must be mut. Yes, no. Oh, it's yeah, it must be mut, but it's also we should have star here. So should get value for reference like this or something. I'm not sure how it called in Rust, but in the C++ it will be from the reference get the value. And it has some specific term. But yeah, let's run it. And it works. But maybe there is explanation, yeah, about the star. To change the value the mutable reference refers to, we have to use the star, the reference operator to get to the value in I before we can use the plus equal operator. We'll talk more about the reference operator in the following the pointer to the value with the reference operator section of chapter 15. Okay. Somewhere in the future, chapter 15. Smart pointers. Very interesting. Iterating over a vector, whether immutable or mutably, mutably is safe because of the borrow checkers rules. If we attempt to insert or remove items in the for loop bodies in listing 87 and listing 88, we would get a compiler error similar to the one we got with the code in listing 86. The reference to the vector that the for loop holds prevents simultaneous modification of the whole vector. Yeah, makes sense. I think I had some problems somewhere when I studied in the university and tried to modify the array or something in C++ during the loop, and I got the error, etc. And Rust don't allow it, so we even can try like we push we push 50 and cargo build and cargo build. Okay. first mutable board here and then it's again board. Yeah, doesn't work. So using an enum to store multiple types. Okay. Vector can only store values that are the same type. This can be inconvenient where definitely use cases for needing to store a list of items of different types. Fortunately, the variants of enum are defined under the same enum type, so when we need one type to represent elements of different types, we can define a use and enum. All right. So for example, say we want to get values from a row in a spreadsheet in which some of the columns in the row contain integers, some floating point numbers, and some strings. We can define an enum whose variants will hold the different value types, and all the enum variants will be considered the same type. That of the enum. Then we can create a vector to hold the enum and so ultimately hold different types. We've demonstrated this in listing 8, 9. So in float text, spreadsheet cell. Okay, let's quickly write it down. Enum spreadsheet, and we want int I32 float f64 and text will be string. Yeah, uppercase should be here. Then let's comment out this and let's create row with vec macro. Then spreadsheet entry and spreadsheet cell text string from blue. And let's print it out. Print one. So derive debug macro. I don't remember how to write it, so I hope the Copilot will help me, but it's not what I'm looking for. So Rust derive debug. Okay. Hashtag derive square bracket derive debug. Hashtag square brackets derive. Okay, now you do it. So cargo run, and we got printed our vector with different values. implemented through enum. Okay. So Rust needs to know what types will be in the vector at compile time, so it knows exactly how much memory on the heap will be needed to store each element. We must also be explicit about what types are allowed in this vector. If Rust allows a vector to hold any type, there would be a chance that one or more of the types would cause error with the operations performed on the element of the vector. Using an enum plus a match expression means the Rust will ensure at compile time that every possible case is handled, is discussed in chapter 6. So yeah, again, it's all about the safety. If we exactly specify which type we can use in the enum and then use it in the vector, all cases can be covered by Rust in compile time, and we are in safe world. If you don't know the exhaustive set of types a program will get at runtime to store in a vector, the enum technique won't work. Instead, you can use a trait object, which we'll cover in chapter 17. Okay, this is something close to the end of this book, because final project is chapter 20. 9 is advanced features, and 17 is about of the end. Okay, now that we discussed some of the most common way to use vectors, be sure to review the API documentation for all the many useful methods defined on the vector T. Okay. By the standard library, for example, in addition to push and pop methods, remove and return the last element. So pop method removes and return last element, and let's quickly find it. Yeah, you see the methods, and there is pop method. We can find it, the pop function pop itself, remove the last element from the vector and returns it, or none if it's empty. If you like to pop the first element, consider using vector dequeue pop front instead. So this is different vector, I guess. Vec_dequeue. The default usage of this type is a queue is to use pushback to the queue and pop front to remove from the queue. Extend and append pushed into back in the manner. So yeah, for different use case like this, we have different vector type. Okay, so dropping a vector drops its elements. Like any other struct, a vector is freed when it goes out of scope, as annotated in listing 810. Okay, V goes out of scope and is freed here. This is fine. When the vector gets dropped, all of its content are also dropped, meaning the integer it holds will be cleaned up. The borrow checker ensures that any reference to contents of a vector are only used while the vector itself is valid. Let's move on to the next collection type, string. So the next section is the string, and I'm going to read this section on the next stream. And now I would like to try Rustlings. Let's find out how it works. Maybe do it a bit bigger. Maybe I can move the camera on different side here. Okay. Greeting and welcome to the Rustling. This project contains small exercises to get you used to reading and writing Rust code. This includes reading and responding to compiler messages. Looking for the old web-based version of Rustling? Try here. No, I'm not looking. Alternatively, for the first time Rust learner, there are several other sources. The book, which we're actually reading, the most comprehensive source, and Rust by example. Learn Rust by solving the exercise. It's almost like Rustling, but online. No, we won't do it on our end, not online. Getting started. Note, if you're on macOS, make sure you install. Yeah, we already installed the Rust, so we're fine. Now macOS Linux, just run. Let's do this. So this fiction, while it is, let's look my pass and default pass. Okay, Windows browser, manually doing exercise. The exercises are sorted by topic and can be found in the subdirectory Rustling exercise topic. And do it actually install Rust? Okay. I think I would love to move Rustlings to Rustlings like this. And maybe even from the Rust book directory, because it's not Rust book, so Rustlings is here. Let's look at it. SRC, there is exercise. Project run. Exercises. Okay. I think this is our exercises. So the exercise is sorted by the topic. It can be found in the subdirectory Rustling exercises topic. For every topic there is an additional readme file with some resources to get you started on the topic. We really recommend that you have a look at them before you start. The task is simple. Most exercises contain an error that keeps them from compiling. Okay, and it's up to you to fix it. Some exercises are also run as a tests, but Rustling handled them all the same. To run the exercises in the recommended order, execute Rustling watch. And where should I do it? Let's create new new tmax section, Rustlings, about you do. Sorry, do rust, the rust links. So rust links watch. Just curious, can I do Rustlings? Okay, must be run from the Rustling directory. Okay, this is clear now. We should be in the Rustling directory. And Rustlings watch. So code is compiling. I'll put hello, welcome to Rustlings. This is exercise compile successfully. The remaining exercise contain a compile or logic error. The central concept behind Rustlings is to fix this error and solve the exercise. Good luck. The source of this exercise is in exercise intro RC. Have a look. Going forward, the source of the exercise will always be in the success failure output. If you want to use Rust Analyzer, Rust's LSP implementation, make sure your editor is set up and then run Rustlings LSP before continuing. You can keep working on this exercise or just into the next one by removing the I'm not done comment. Okay, welcome to watch mode. You can type help to get overview of the commands you can use here. Okay, so maybe let's split the screen and let's open nvim here and Rustlings watch on the right. Okay, okay, do Rustlings watch. So not sure where to place better camera so far, but yeah, let's go to the exercises, intro 1. So sometimes encourage you to keep trying things on a given exercise, even if even after I already figured it out. If you got everything working and feel ready for the next exercise, remove the "I'm not done" comment below. Exercise rustling hint intro. So yeah, to finish this one, just we need to remove this "I'm not done." Execute rustling hint intro 1 or use the hint watch subcommand for hint. If you are running this using rustling watch, the exercise file will be reloaded when you change one of the line below. Try to edit print line or try changing what it outputs in your terminal. Try moving a semicolon and see what happens. So what the extra exercise here? Is it actually exercise or just... Okay, I'm not done. So we need to go to intro 2. Okay, make the code print a greeting to the world. Execute rustling hint intro 2 or use the hint watch subcommand for a hint. So yeah, basically there is... Do it in several ways, but let's do simple as it is. And we're done with our first exercise, I guess. And we can move forward. It's quite fun, I guess. Yeah, but it might be not the best place of the camera so far. Maybe let's move it somewhere here. I don't actually know, maybe... Okay, let's put it here for now. And variables 1. Okay. So here's the variables 1. Make me compile. Execute Rust new hint or... Okay. So I guess the let is missing here. And we are done. Execute. So there is an error. Considering X an explicit type. Or can we do it like this? Yeah, we still have to do something like this. Okay, this could be a fast run. So used binding x isn't initialized, yeah, as before. And we are good. Moving forward. Cannot assign twice to immutable variable x. Don't change this line. Okay. So we add mat and we are good. Yeah, this is feel like warm up exercises. Not the real one yet, but mismatched types. Expected str number 3. Don't name this variable, don't change this line. So yeah, this is a bit more interesting. So I guess in chapter about variables, we can just redefine the variable and don't worry about previous version, and we are fine. Yeah, at least we are good at variables after reading 7 chapters. Anyway, so number 3 have missing the type for the const variable. I don't remember much about the const, but if we just add type here, will it solve the issue? Okay. Okay, I think but yeah, let's actually take a look. Let's move maybe camera back here, and I wonder about the constants. And the type of the value must be annotated. So yeah, this is the rule that the const must be annotated with the type. Okay, I think this is enough. And we're done with variables. We can go to the functions. So cannot find function call me in this scope. So we just add the function and we are done. Expected type found. So basically, yeah, there is Rust analyzer said there is an error and we expect the type, and let's do i32 and we are good. Function expect the number, but unfortunately Rust analyzer did not say anything about it, but I expect it should, but whatever. Let's put some number here and we should be good. Um, okay, make it output a bit shorter. We are done. Next function 4. So let's see. Okay, expected return type, as I see it's same as an argument, and we are good. Mismatch types. Oh, this is fun error. So it says expected I32, but we got unit type or empty loop. So if we do like this, we are good. Or we can just remove semicolon and end, and the value will be returned. Yeah, we don't really need to read me at this point. What is the next exercise? Exercises if. So if 1 expected I32 found empty, yeah, sounds something similar. Complete this function to return the bigger number. So if A bigger than B, then bigger A and B. Okay. So yeah, so far the Rustling exercise super simple. I am not sure if there is any comment required. It may be helpful for super beginners, or if you haven't read Rust book, but I don't think it's the only way I see good to learn Rust is just read the book. I don't know, it's something about Rust. I don't think it's the best way, maybe for JavaScript or something like that, but maybe if there is a good book, it's always fine to read it. If you need to start faster, maybe you can use different resources. For example, with React, it's not the language itself, but React JavaScript, I started with some good Udemy course, and then I practiced, then I back to some materials, books, courses, watch CS50, and there was really good CS50 course about React Native, for example. I forgot this university name, not Stanford, it. Oh my gosh, whatever. But yeah, I don't know. With Rust, I feel it's so many concepts you need to learn. It's different from other world of programming. Maybe if you don't know anything about programming, it's always good to start with something fundamental, like fundamental book. Maybe not. It depends, but yeah, for us, I feel, at least for me, it's the only way you should start with the book. So let's back to this exercise of the rustling. What is the error? Expected string reference, which I get some name. I don't remember which. Let's quickly look into the book. So the slice type, and this is, I think, the string slices. The type that signifies string slice is written as, so this is string slice. Okay, so let's read expected string slice because of return type. And we return 1 here. Foo if fees, but make compile, get the bar for fuzz, and default to bus test passing. So if we pass fizz at return foo, and we foo if fizz, so we expect to return bar here. Okay. Now default to bus. Default to bus foo if fizz. Okay, if else if fizz fast, and this is bus, and we are done. And quiz one. So Mary is buying apples. The price of an apple calculated is follows. An apple costs 2 rust bucks. If Mary buys more than 40 apples, each apple only costs 1 rust bucks. Write a function then calculate the price of an order of apple given. And the quantity, but no hints this time. Put your function here. If calculate price of apple. So I need the function which num I set it to and return I guess as well. Okay. Now cost 2 bucks. So if Mary buys more than 40, so num is more than 40, then we return num multiply by 1. If not, num multiply by 2. Oh, this is whole quiz. Okay. Yeah, it was funny warm up, I guess. We played with Rustlings and think we can finish all 94 exercise. I think it will be complexity should grow, and there is, I believe there will be option, ownership, something like this. Yeah, lifetimes. That's pretty interesting concepts. So the vectors are here as well. So we crush it at 111 on the next streams. today is over. Yeah, it's like midnight and I'm going to finish streams. Thank you for watching. See you next time.